Right, boys, so this is where we get into the harder word problems. So let's read the first one here. A triangular orienteering run starts at alpha. So we're going to start by drawing up our compass rose, and in the middle we're going to put A for alpha because that's where it starts. And it passes through the checkpoints of Bravo and Charlie before finishing at alpha. Bravo is 8.5 kilometres due east of alpha. All right, well, there's alpha. We're going to go due east, go straight towards the east, and we're going to get to Bravo. So we're going to put B for Bravo there and put the 8.5 kilometres on here. Now, the next thing says, and Charlie is 10.5 kilometres due south of Bravo. So there's Bravo. We're going due south, which is straight down. We could draw up a new compass rose here, but I'm sure you can see that south of Bravo would be straight down. And that's where Charlie will be. And that's 10.5 kilometres. So on this orienteering course, they start at Alpha, they go to Bravo, go to Charlie, and back to Alpha again. So there's our triangle. I'm sure you can see that we will have a right angle in here because we went east and then south. And so we've got a right angle triangle to work with. Now it says in the first question, calculate the distance from Charlie to Alpha. There's Charlie, there's Alpha. We're looking for this side here, the length of it. So we're going to call it C. And we can just use Pythagoras' theorem on this because we have two sides and we're finding the third side. So if we use Pythagoras' theorem, we've got C squared equals A squared plus B squared. C squared equals 8.5 squared plus 10.5 squared. Then work all the way down through to your answer here. And then we're doing 3 decimal places, so we're rounding off at 3 decimal places, which will be 13.509 kilometres. Now in part B, they want you to find the bearing of Alpha from Charlie. Whatever's written after the word from is in the middle of your compass. So it's from Charlie. Charlie is in the middle of the compass. Well, there's Charlie, and at the moment it's not the middle of the compass. So I'm going to get my red pen to draw a new compass around Charlie with Charlie in the middle. Okay, so we've got our capital C for Charlie in the middle of that compass. Okay, so now we are trying to find the bearing of Alpha from Charlie. So we're going to go all the way around on our new compass, north clockwise till we hit that line, and that's what we're trying to find to get our answer for the bearing. So the first thing we need to do is to find this little angle in here. Okay, so we're going to find that angle here first. We're going to call that theta, and it's inside our right angle triangle. So if we label our sides, this is our opposite side and our adjacent. So we're using tan. So it's tan theta equals opposite over adjacent. Tan theta equals 8.5 over 10.5. Go through your working like we usually do, getting rid of your tan. And you end up with, on your calculator, theta equals 38.99, etc. degrees. I haven't gone to minutes because we are doing a bearing question here, and bearings generally are in degrees. This question did say answer to the nearest degree, but I haven't put that on there. So now we're going to find the bearing. So we want this red bearing here. So we're going to get 360 degrees all the way around and take off that little piece we just found. And then you'll get your final answer to the nearest degree, 321 degrees. Wait till the music finishes. It's Mr. Ritchie's pick. Okay, all right, so we're up to example 4. All right, so we have 2 horse riders that start from the same stable. The rider of the black horse goes due west for 5.5 kilometres and stops. The rider of the chestnut horse travels in a direction of 303 degrees until he is due north of the black horse. So there's a lot to think about in this question. So, if we have a look at our diagram, we're drawing north, south, east and west for our diagram. Our first horse, the black horse, I'm using the black pen for, so he is going due west for 5.5 kilometres. So he starts at the stable S, straight off due west to some point, and that's 5.5 kilometres that he's travelled. Now for the chestnut horse, I'm using my blue pen. He's going into a direction of 303 degrees from that same stable. So 303, go north clockwise through 303 degrees and we'll be around here somewhere. Draw off your line for your chestnut horse. Now, he keeps riding until he is due north, okay, of the other horse. So watch what happens. Right, so off he goes. Here's the black horse, and he's going to keep going until he is due north of that horse there. So in other words, they want that to be a vertical line. All right, so this is your chestnut horse, C for chestnut. This is your black horse, B for black. Okay, so you can see from the diagram that, I think we've got everything on so far. Yep. So from the diagram, you can see now that we do have a right angle triangle. And if we work a little bit more on this angle here, because we've got a bearing here, we should be able to find this angle near this bearing inside the triangle. So if we do 303 minus all the way around to there, which was 270, 303 minus 270 will give you 33 degrees as an angle inside here. Okay, now the question says, how far did the rider of the chestnut horse travel? Well, the chestnut horse started here at the stable and rode up there. That's him there now. So we're looking for this distance here. We'll call it X. Now we're going to label our sides inside the triangle. This is your hypotenuse. This is your adjacent. So we're using cos. So we're going to be doing cos theta equals A over H. Cos 33 degrees equals 5.45 over X. Now remember, when you've got the letter on the bottom, these things swap spots. Right, so letter on the bottom. Okay, so once they swap, it's going to say X equals 5.5 over cos 33 degrees. Put that in your calculator, use your fraction key to do it. And then when you get your answer, they want the answer to two significant figures. So it's 1, 2, draw your line there for rounding. This is 5 or more, so this will go up by 1, and your answer is 6.6 kilometres. Okay, now the next question has a lot to do. So I'm just going to move this over here a little bit. All right, so there is a fair bit to do on this question. All right, so just making sure we can see it all. All right, now the question itself says, two ships leave from the same port. So again, we're going to be drawing up a compass. We've got the port at the beginning here. They're leaving from the same port peak. One ship travels on a bearing of 157 degrees at 20 knots. So I'm going to use my black pen for that. Now, it travels on a bearing of 157 degrees. So we're going from north, that's the black pen, 157 degrees will get us to here, and that's the first one. All right, so that's the first ship that we've got here. I'm going to call it F for first. It's gone to there. Now, knots are, it actually tells you a little bit further down here. 1 knot is a speed of 1 nautical mile per hour. So the symbol for nautical mile, you don't really need to remember this. Just write the word nautical mile if you can't be bothered with the capital M. But it is a capital M. the symbol for it. Okay, so we actually need to go to our distance, speed, time triangle I've taught you before, because all I've done at the moment is turned the ship in the correct direction, but we don't know how far it's going. We know what speed it's going. It's travelling at 20 knots, but we don't know how far it went. So we can't write a speed on a line. A lot of the weaker students will write speeds on lines in a triangle. A speed is not a distance. Okay, so you need to actually find these distances using this formula. Okay, so to find distance, we're going to do distance equals speed times time. So this first ship was doing 20 knots, which is 20 nautical miles per hour. Now it does tell you in the question that down in part A it says they are travelling for 8 hours. Okay, so we do know the time as well. So 20 knots or 20 nautical miles per hour times by 8 hours gives you 160 nautical miles. So now we know what distance it travelled for. We can write, I know there's a lot on this diagram, so be careful, 160 nautical miles. That's how far that ship went. Now the second ship, it travelled on a bearing of 247 degrees. So I'm going to use my blue pen for that. Go 247 degrees takes you around to here. Draw your line off, S for second ship. That's 247 degrees. Okay, now it travelled at 35 knots. So we're going to find the distance it travelled over here. So distance equals speed times time. This ship travelled for 35 knots or 35 nautical miles per hour. And we want to know how far it went in 8 hours. And it works out it went 280 nautical miles. So we put that on that line. Now, in part A, it says how far apart are these ships? Well, if you look at the diagram that we've got so far, so we've got the first ship travelling over here, the second ship travelling here, and we need a triangle, so I've joined these two up so we can see our diagram. Now, if you have a look at the two bearings they had, 157 to here and 247 to here. Well, if you do 247 minus 157, you will get 90 degrees. So you actually have a right angle in that corner. So it is a right angle triangle. So in the first part where they say how far apart are these two ships, well, here's your first ship and here's your second ship, all you're finding is your hypotenuse. So we're going to use Pythagoras' theorem and find that hypotenuse, because we do have the two lengths in the right angle triangle. So c squared equals a squared plus b squared. C squared equals 160 squared plus 280 squared. And if you follow through the working and round it off to the nearest nautical mile like they asked, you're going to get 322 nautical miles. Okay, now the trickier question, that was pretty fiddly because we had to convert the speeds and everything to distances, but part B is even trickier. So we've got to be a bit careful with this. In part B it says calculate the bearing of the second ship from the first. Whatever's written after the word from goes in the middle of your compass. So the first ship has to be in the middle of the compass. So what I've started to do here is, there's your first ship. I've started to draw a new compass up in red over there. It's got to be from the first ship and that's got to be in the middle of the compass. So we have to find the bearing of the second ship. So we go all the way around till we hit that line, and that's the bearing that we're trying to find. Question mark. That's our bearing. Trying to find that. Okay, so let's see what we can find. Now, if you get into an exam and you're going, I don't know how to do this, just start finding angles. Any angles in the triangle that you think might help, you might get some marks. Don't panic. They're not meant to be real easy, but think about them. Okay, so what we're going to do to start with is we're going to find just working out which colour to use here. Yeah, we'll use the black one. Okay, we're going to find this angle here. We're going to call it theta. Okay, so when we do that, we go tan theta. It's going to be tan because this is the opposite side and this is the adjacent side. So tan theta equals O over A. Tan theta equals 280 over 160. And go through and find your angle. Now, because we're doing bearings, I have rounded this off to the nearest degree. It didn't work out to be exactly 60 degrees, so I have written equals approximately 60 degrees. But it doesn't matter, just write 60 degrees, it's fine. Okay, now we're going to try and find the bearing. So we've just found that angle there to be 60 degrees. Now, I thought I knew what I was doing here. This is what I actually did. I said, well, that's 160 nautical miles for that ship. This one's going 280 nautical miles, so that's obviously got to look longer than this one. So I drew it all the way down here. Now, as it turns out, it doesn't look right now because you have to think about this. If we find all the other little angles that you can find, they will all help. Okay, so in here, if that's 157 going to there, this little gap here will be 180. Take away the 157, you'll get 23 in there. We also know that this is a right angle. So if that's 90 and that little bit's 23, this bit will be 90 minus 23, which is 67. Down here on our compass, because of alternate angles, if that's 23, you have a Z shape forming between these two, with the two north-south lines, so that'll be a 23 in there. And because of a right angle that you have between north and west, that little bit will be 67. So find all those little bits and pieces and see what happens. Now, if you look at what's going on here, I've mucked this up, the drawing of it, because it's not easy to get the actual drawing right in the beginning. So if that is 67 from there to there, how can this whole angle be 60? It doesn't make sense, so I have to redraw part of my diagram. So I'm going to do that over here. I'll just turn this screen around so you can see what I'm doing. So I'm just going to redraw over here what should have happened. I'll just try and keep in the same colours so you can see what's going on. Okay, so far that's what's going on, all right? So what I've done is redrawn it so that this second ship is actually up here and not down further down in this quadrant. Okay, and now we're going to mark in what we've just found. We found the angle inside that triangle over here was 60. Okay, we also know, what else do we know? We'll fill in all these other little numbers so we can see what we're doing. Okay, so I hope you can see all that. Just zoom in on it if you can't. So we've got 23 degrees here and 67 from our earlier diagram. With alternate angles, we'll have a little 23 in that spot there. Now, because of your right angle between north and west here, this piece that I've marked here from here to here is 90, take away 23, so you've got 67 in there. All right, so now, if you look at what we've got 67 for this bit. That's 67. The bit inside the triangle is 60. So that leaves this little piece here, this little gap, to be 67, take away 60. So you've got 7 degrees sitting in that little spot there. And we need that because the bearing is almost done now. So to get your bearing, we're going to go from north all the way through to west, that's 270 degrees. And then we're going to add on this little piece here that we just found, which is 7 degrees. And you get your final bearing of 277 degrees. So I know that question is really tricky. You're not going to get anything harder than that one. But just persist with it, all right? Don't give up on them easily. Just do it slowly and try it. And I don't think there might be one question in the homework like this, but gradually work through the easier problems before you get to something like this. If you're having trouble with it, with any of the homework, please let me know. Okay, good luck.